Kia ora Year 11 and 12. Here's question 1B from last year's paper. Now this one's a little bit harder than 1A. It's a merit question, and if you're watching this when I've just published it, we actually haven't done this in class yet. But if you watch, you'll probably pick up the idea. So the question is kind of weird compared to what we've been doing so far with a whole lot of functions, f of x and y. It's a word problem, right? Your favourite. So we've got a rectangle, and for some odd reason it's expanding in area so that at all times its length is 3 times its width. Find the rate of change of the area of the rectangle with respect to its width when the area of the rectangle is 75 centimetres squared. So you know that I'm going to tell you to start by defining some variables and drawing a diagram. So let's draw, badly, a rectangle. Let's call the width x and let's call the length 3x. Now I'm saying that because we're told that at all times the length is 3 times its width. Right, so let the width be x. Now it's worth writing that down. So let the width be x, and then the length will be 3x. That means that the area is going to equal the length times the width. So that'll be 3x times x. And that gives me an expression for area of 3x squared. Now, what are we asked to find? This is kind of like translating this into maths talk. Well, we're looking for the rate of change of the area with respect to its width. So that's kind of code for saying, as the width is increasing, how much is the area increasing? So we know that if the width is increasing, the length has also got to be increasing because one of those is always 3 times the other. So what we do here is we say, well, let's look at the rate of change of the area with respect to the width. So we write that as dA by dx. So far in class you've just seen us going dy by dx, right? But that's because we had an expression where y was equal to, I don't know, x cubed plus 59x. So we'd go dy by dx is equal to blah blah blah. Right, 3x squared plus 59. So it's exactly the same idea here, except that instead of y, we've got a for area. So differentiating that with respect to x gives me 6x. Okay, so I take the 2 and I bring it down just like we always do. Now, what's the last thing that I have to do? Well, I have to work out, this is the rate of change of area with respect to x. Okay, but we've got a specific question. Find the rate of change of area with respect to the width when the area is 75 centimetres. So I need to figure out, if area is 75, what value of x do I have? In other words, what's the width? So we're going to solve 75 is equal to 3x squared. 25 is equal to x squared. So x is equal to 5 centimetres. So x is equal to 5, which gives me dA by dx is equal to 6 5s. 6 5s are 30. And my unit is squared centimetres. Sorry about the background singing. It's school holidays. So there we go. The rate of change in the area when the area is 75 centimetres is 30 centimetres squared per centimetre. Now don't freak out if this unit is something you're not comfortable with. You don't really have to get those completely in level 2. We'll come back to those in level 3. But basically we're saying, what is the unit that goes with area? Well, it's centimetres squared. And what is the unit that goes with the width or the length? It's centimetres. So the rate of change is 30 centimetres squared per centimetre. You might want to think about it as, if you think about speed of a car, which is also a rate of change, it might be 50 kilometres per hour. Okay, so it's the same idea. All right, thanks for watching. I'll be back with 1C soon.